So in this segment we're going to be talking about factoring trinomials, and factoring means to change into a multiplication question. So with trinomials, the multiplication we're going to make is a multiplication of two binomials. So we're going to move forward with multiplication before we start working about going backwards with the factoring, just to review. So if I have two binomials and I'm going to multiply them together, my diagram is going to look something like this. And there's my two factors, x plus 1 times x plus 2. My product is going to be found here in the middle, and that's going to produce a trinomial that looks like that. And my answer therefore is going to be x squared plus 3x's plus 2. Mathematically, it would look like this. And so there's my answer to my multiplication question. I've given you the factors, and I want to find what the product is. When I ask you to factor a trinomial, however, we want to make sure the students understand that I'm going to give them the product. I'm going to give them the x squared plus 3x plus 2, and I want them to find the sides. So I want to just kind of reverse the whole process, and I want them to find out what the factors are going to be. So just like we've talked about 6 divided by 2 equals 3, and then 3 times 2 equals 6, we can take a division question and change it into a multiplication question. We can take a multiplication question, get the answer, and change it in the opposite direction into a factoring question. So when I give you a division question, x squared plus 5x plus 6, and I want to divide it by x plus 2, we've done this with division before. The x squared plus 5x plus 6 is going to be found here in the center, and one of my factors is going to be x plus 2. What's the other side have to be? So we're kind of working towards finding the sides, and so now we know what the inside, we know one of the factors, find the other factor. And I have my x squared, my 5x's, and my 6's. They've got the x plus 2, so it has to have an x plus 2 down this side, and that tells me what configuration I have to put these in. I could have 6 in a big long string, but then that wouldn't make my rectangle anymore. So the only way that I can make 6's are 6 times 1 or 2 times 3, and I know that I have 2 here, so I have to have 3 there. So my answer is going to be x plus 3 across the top, and so my answer is x plus 3. And so it would look something like that. And then again, talking about reversing our multiplication and our division questions, if I take my divisor and multiply it by my quotient, I should be able to get what I started with. And x plus 2 times x plus 3 gives me x squared plus 5x plus 6. So again, we started off with a division question. It gave us a clue as to what things have to go down this side to give us a little easier idea of what to find the answer. When we go to do our factoring of our trinomial, we won't have any clues, and we'll have to work our way through that. So I think it's a good idea to start off with some things that students know, multiplying, then a division, before we have to figure out the two blanks on the outside. And we'll do that next. When we give a question like this, and we want them to factor the trinomial, it's very tempting for teachers, myself included, to just go ahead and tell them what two numbers multiply to give me 12 and add up to give me 8. The problem is they sometimes forget that rule, they get confused with it, especially if there's positives and negatives, and so I think it's really important for us to give students an opportunity to create that rule themselves so they can really own it and understand it. And I think it's possible, I've done it in my class before, if we give them a series of guided questions, they will come up with that rule themselves. So I'm going to give you some guided questions here that in the order that I would think I would present them. So I would start off with a family of questions and ask them what's the same and what's different about these questions. Give them an opportunity to talk amongst themselves, and then as a group come back and find out things like they all have x squareds, they all ended in a 12, they all have a certain number of x's, they all have positives. What's different? Well, the difference is it's just in the middle terms here, and have them come up with that. Then we're going to do the drawing and see how the drawing is affected by the equation, or how the equation is affected by the drawing. So here's all our pieces, but unlike the division question, we have no clues as to what's supposed to go there. So we start off with our x squared. Our x squared is pretty straightforward. To get an x squared, we have to have an x and an x. So that takes care of that piece. Now down here, I've got my 8x's. That looks like I might have 3 and then turn these sideways to have 5, so I'll try that. And I might get something that looks like that. So I got my x squareds working. My x's seem to work, but my 1's are all gone. they're not right. I've got 12 x's here and I need more because it's a 5 by 3, so that doesn't work. So I look at that and I say, well, the 5 by 3 doesn't work, but 5 times 3 is 15. I need 12, so maybe I should change it to a 4 times 3, or maybe a 6 times 2, or a 12 times 1, and let them play around with it and see which one works out. And eventually they'll come up with this, and that comes out to x plus 2 times x plus 6. Now in the process of finding that, they may get some things that add up to 7x, or they may get up some things that add up to 13x, but the ones don't work. That's okay. As they work their way through that, they find some of these other ones in the family that will give them incorrect answers, but a clue as to what to do on these next ones. So they'll let them solve these next couple and find their answers. Now some of them might see a pattern going on here with just these 3 alone, but some students may need a little bit more practice to be able to see the pattern. So we'll do some more. We'll do another family that's still related to this family. So if we're working with this family, we could ask, how is this family of 3 the same or different than this family of 3? Most students, again, give them time to work on it, and they'll say that the x squareds are the same, the 12s are the same, and the 8s are the same, except one's a positive and one's a negative. So what would that mean to our diagram here? So we still need to have an x squared, we still need to have 8 x's, and we still need to have 12 1s, but all my x's have to be red. So some students might just change all the x's, and they go, well, wait a minute, that doesn't work. X times x gives me x squared, but positive x times positive 1 doesn't give me a negative x. Now, do I need to change this color? But if I change this one, then that changes that. What happens if I change these guys up here at the top? So I'm going to do that next. And I see that takes care of my x problems along the top. But then I have the same problem down here. I have an x, a positive x, and a positive 1, so these ones might have to be negative. And that takes care of my x problems. But are my 1s okay here? A negative times a negative gives me a positive, so I'm okay. So that's what my answer has to be. So now I have a positive x squared, I have 8 negative x's, and positive 12. Again, the numbers don't change, but the signs do. So I have x minus 2 and x minus 6 across the top here as my factored version of that. I would then give them time to play around and see if they can find the factored versions of these ones. And once they've got them all, we put them on the board, and we again take a look to see if we can see any patterns. How are these the same or different than these? How are these the same or different than these? And some students will now notice that, okay, 2 times 6 is 12, and negative 2 and negative 6 gives me my negative 8, the numbers that multiply and also add up. Some students still may not see that, or they see that, but they have difficulty with the next set. So my next family would look like some of them positive, some of them negative. So on this one I have my x squared. I'm just changing my colors. I need negative 12, so I changed all these to reds, but I need 4 negatives, so I just changed some of these to green. But then if I had 4 negatives and 4 positives, I wouldn't have any x's at all. Those would be 0 pairs, so that wouldn't work. So this one's problematic because I need 12 of these red guys. How do I arrange my x's in order to do that? And let them play around with them for a while. And they'll get to this point. So my x squared, x times x gives me x squared, 1 times x gives me an x, so those are all good. X times a negative 1 gives me negative x's, and a positive 1 times a negative x, positive 1 times a negative 1 gives me a negative 1. But I seem to have an awful lot of pieces here, and so what they have to recognize is that I've got some 0 pairs. This one here and this one here cancel each other out. That's a 0 pair. This one here and this one here cancel each out. That's a 0 pair. So what I'm left with is x squared and 1, 2, 3, 4 negative x's. That's what I have here. And my negative 12, which is what I have here. So my answer to this question is going to be x plus 2 and x minus 6. These are a little harder because now we have these extra pieces that have to cancel each other out. But again, with a little bit of practice, they can play around, they can make them. Have them make the following ones as well. And they'll get the following. Now what they want, some students will notice, is that the sign here is negative, and so the one that has the biggest set in the two, the biggest set is a negative. So the biggest number has to have the same sign as my question. My answer has to be negative, so the bigger of the two numbers has to have the negative. My answer is a negative, so the bigger of the two numbers have to be the negative. So they can make that connection as well. And if they don't, you can point that out to them, and or through a series of good questions, see if they can find that out themselves. So the next question you might want to say, okay, we've done three families now. What would be the next family? These are both positives. These are both negatives. This is where the biggest number of these two are the negative. What would we have to change here? What would be our next family of three? And see if they can come up with this family where the other of the two factors is the negative, and see if they come up with that. By the time they go through all four families, they'll pretty much come up with what that rule is for solving how to factor a trinomial with an a value of 1. When we have an a value of other than 1, it's a little bit more problematic to do, but the blocks allow us to do that relatively easily. So we'll let them try to figure out this one, and they'll see it's going to come out looking something like this, or reversed. So we got our 3x squareds, 2, 4, 6, 8 x's, and our 4 1s. So my factors are 3x plus 2 and x plus 2. And mathematically it would look something like that. Now normally we do the FOIL method, but if we do it a little differently, if we say the x has its chance with the whole bracket, so x times the 3x plus 2, and the 2 times the 3x plus 2, that'll lead us into the decomposition technique that we often show as the standard shortcut way of doing it. So let's take a look what that would look like in my picture. So if I take my x plus 2 and multiply it by just my 3x, then I can take, one second, sorry, I had it the other way around. If I say my x multiplied the 3x plus 2, here's my x times the 3x plus 2, and that's going to give me 3x plus 2x, 3x squareds plus 2x's. Then I take my 2 and distribute it amongst its second bracket, 2 times the 3x plus 2, here's the 2 times the 3x plus 2, and that's going to give me my 6x plus 4. I add the two pieces together, and now this is my decomposition technique. My 8x is broken up into my 2x and my 6x. What two numbers multiply together to give me 12? So there's my 3 and the 4. I break down the 8x into 2x and 6x. Cut it in half, in fact, the 2 halves. And that's our decomposition technique. But we can show how that works visually as well. Now some students say, well, does it have to be in that order? Can it be in the other order? And you say, no, it doesn't make any difference. So let's show that. Some students say, does it matter which order you do it in? No, not really. Some students would say, well, if I took the x plus 2 and multiplied that by the 3x and the whole x plus 2 and multiply that by 2, would it still work? Yes, it will. So let's cut that diagram up and move things around a little bit. So when I take my x plus 2 and multiply it by my 3x, here I'm going to get my 3x squared plus 6x. And when I take my x plus 2 and multiply it by my 2, that's going to give me 2x plus 4. Either way, I'm going to get my 3x squareds, 6x and 2x, and my 4. So it's a visual way of showing that it doesn't matter how you break it up, it still gives us the same answer. So we've shown how that shortcut or the decomposition technique works, but it also shows the guess and check technique of how that might work. And as long as the x squareds are relatively few combinations, and the third variable, the c term, has relatively few combinations, the guess and check technique will work just as well.